Alright, so today we're going to be learning the fundamental theorem of calculus. So the good thing about this fundamental theorem of calculus is we're not going to have to do sigma and Riemann sums anymore. Remember on the previous test when we had to write our whole Riemann sum when the limit as n approaches infinity of whatever? That now we're not going to have to do that anymore. Now it's going to be so much more simpler and so much more easier, right? But we do have a couple steps that we're going to have to follow. So this is for the steps to find the integral, right? And then this is the steps to find the absolute value of some integral. The absolute value just requires just a little bit more steps, but it's essentially the same. It's pretty easy. All right, so for the steps for the integral, you have to write it in integral form. Then you have to find the antiderivative. You have to plug in your interval, and then you have to just answer using algebra, right? All right. So first, let me tell you what the fundamental theorem of calculus is, right? So let's say we're finding the integral from a to b of whatever function, right? So that's just saying the antiderivative evaluated at b minus the antiderivative evaluated at a. And just some requirements is that the function has to be continuous on the closed interval a to b, and big F, this is capital letter F, is an antiderivative of f of x, right? Then if both these requirements are accepted, then you can use the fundamental theorem of calculus. So here let's use our first problem, right? So here they're giving us a function, right? And they're telling us evaluate it at 0 to b. So first, remember, we have to write it in integral form. So from 0 to 2 of 2x squared minus 3x plus 2 dx. Alright, and so now that's good. Now we have to find the antiderivative, right? So that's 2/3 minus, so that's 3/2 plus 2x, value at 0 to 2. So now this is our antiderivative. So now we're just gonna have to plug in our intervals, right? So remember, the antiderivative evaluated at b minus the antiderivative evaluated at a. So first I'm just gonna do b. So it's gonna be 2/3, 2 cubed minus, all I'm doing is plugging in 2 every time I see an x, right? So that's our antiderivative evaluated at b minus, right, evaluated at a. So that's 2/3, 0 cubed minus 3/2, 0 squared plus 2, 0. So here we can obviously see all of this reduces to 0, right? So let's just focus on this now. So this is 2/3 times 8 minus 3/2 times 4 plus 4, right? So here, so this will be 16 divided by 3 minus, we can take that to 2 minus 6 plus 4. So this will be 16 cubes minus 2. So the answer is 10/3. So see how that's so much more simpler than having to find our Riemann sums and all that sigma. So now by using the fundamental theorem of calculus, we could find this so much more easier, right? So now let's do the absolute value, because a lot of times whenever we see absolute value, we don't know what to do, and we think it's so much more complicated, but actually it just requires just a little bit more steps, but it's essentially the same. So for the steps for absolute value, you just have to add 3 more steps, right? First, you have to find the 0. So when the sign changes, right? Then you're going to have to write it in piecewise function, and then you're going to have to split the integral into 2 forms, right? One when it's positive and one when it's negative. So and then you use the same steps again for the integral after you have done those 3. So let me do the absolute value. So here, we're gonna find when x is equal to 0, right? So we can see that that's when x equals 1/2. So when x equals 1/2, we know the sign changes, right? So let's figure out if it's negative or positive or how it is. So here I'm gonna plug in 0 as our test value, and here I'm gonna plug in 1. So if I plug in 0 here for x, we can see that it's negative, right? If I plug in 1, we can see it's positive. So now we're going to have to write our piecewise function, right? So 2x minus 1, absolute value. Alright, 2x minus 1. When it's negative, right? Yeah, negative. When x is less than or equal to 1/2. And then it'll be 2x minus 1 when x is greater than 1/2, right? So now we wrote in piecewise function. Now we're going to have to split into two separate integrals using these, alright? And we're just going to add them together. So here, let's write over here. So the integral 0 to 2 of negative 2x minus 1 dx plus the integral of 0 to 2 of 2x minus 1 dx. Oh, what am I doing? I'm sorry. It's 0 to 1/2 and then 1/2 to 2. Okay? The reason I did that, because remember at 1/2, that's when the sign changes, and that's when we're using our different functions, right? So now that we wrote into two separate integrals, now we can use our steps, right? That we did over here. Now it's basically exactly the same thing, right? So first, remember, we already wrote it in integral form. Now we're gonna have to find the antiderivative, right? So I'm just gonna rewrite this, and I'm gonna spread out our negative value, because that always confuses me, the negatives. But that you don't have to do that. All right. So now the antiderivative. So that's negative x squared plus x evaluated 0 to 1/2 plus x squared minus x evaluated at 1/2 to 2. Alright, so remember now the antiderivative value at b minus the antiderivative value at a. So first I'm just going to work with this, right? So it's going to be negative 1/2 squared plus 1/2 minus negative 0 squared plus 0. So this reduces to 0, right? So it's just going to be negative 1/4 plus 1/2, which is this is the same thing as 2/4. So this is 1/4, right? So now we already did this side. Now we're going to have to do this side, right? So it's going to be x squared, 2 squared, my bad. 2 squared minus 2 minus, evaluate at a, so 1/2 squared minus 1/2. So this will be 4 minus 2, which is 2, minus, this is 1/4 minus 2/4. 2/4, same thing as 1/2. So that's negative 1/2. So this is 4 squared plus 1/2, which is equal to 5 halves, right? But we have to add it to these two.
Un cuarto menos 2 cuartos no es 1/2.
Negative 1/4. Sorry. Alright, 8/4. Alright. So this will be 9/4. So now we have to add these two together. So 1/4 plus 9/4 is equal to 10/4, which is equal to 5 halves. So then that's our answer. See, this was just a little bit more complicated because we had the absolute value, but it's essentially the same, right? So that's it for the first fundamental theorem of calculus, right? But I just want to go over the second one just real quick because it kind of ties in, and it's really simple, right? So this is the first fundamental theorem of calculus, so we're not going to worry about that anymore. So now we're going to worry about the second one, right? The second one is really, really simple. So all it says is, if we're finding the derivative, right, of the integral of a function, evaluated from a to x, right? Before it was a to b, right? There were two numbers, right? For example, 0 to 2 or 1 to 3. Now it's a to x. So now it could be from 2 to x squared. This is just a function. X just means it has to be a function, right? So when we're finding the derivative of the integral, it's just the same thing as finding the function evaluated at that function, right? So our requirements is that f has to be continuous on the open interval I that contains a, and then for every x we can use that value, right? So here we have two problems, right? So I'm gonna rewrite over here a little bit bigger so you can see it. Okay. So we're just gonna use this, remember? So this is our function, right? That's the same thing as this, right? So this is our function, and our x value is x, right? So all I'm gonna do is plug in x for t, right? For t. So this whole thing just turns out to be x squared minus 1. That's it. It's as simple as that, right? The only thing that can trip people up is just the chain rule, but you just have to remember to use the chain rule, right? So this will be our second problem. Alright. So remember, our function is cosine of t, right? And we're plugging in x cubed, right? So this will be cosine of x cubed, but then we have to use our chain rule, so we have to find the derivative of that, which is just 3x squared. But that's it. So now that's our answer. And that's the first and second fundamental theorem of calculus.